Method of resolution of a force. The process of splitting up the given forces into a number of components without changing its effect on the body is generally called a resolution of a force. Now, a force is generally resolved along two mutual perpendicular directions. Now, if we look at to the principle of resolution, so it generally states that the algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of their resultant in the same direction. So this is a generalized statement. So whenever you have a algebraic sum of the resolved part, there are two number of parts, and if you make a summation of that, and that is in particular direction is always equal to the resolved part of that resultant. Now, if we talk about further, and if we consider for a simplicity two forces P and Q, so let us say consider first of all the two different axes. Now this is axis X and this is axis Y. Similarly, this is Y dash and X dash. Now, as per the principle, we just consider two forces. That forces would be Q and P. So let us say consider force Q in this particular direction. This is force Q, and second force, that is P, in this particular direction. Now that is generally represented in terms of the magnitude and the direction, and that is considered with two adjacent sides, that is OA and OB. So we take a point O here and B point here and A point. Now if we look at to that OA and OB, and that is nothing but two sides of a parallelogram. So we extend that with respect to the force direction, maintaining the line parallel to a force P, and another line that is parallel to a force Q, and that point is a C point of a parallelogram OBCA. Now you know that the resultant R of forces P and Q, that will be represented by a diagonal OC. So let us we put here, this is a resultant R, that is a diagonal of that OBCA parallelogram. Now here OX is the direction where the forces are to be resolved. Now if we draw a perpendicular line from the A, so that is AL, and from B on x-axis, that is BM, and from C, that line is CN. Similarly, we also draw one parallel line with the x-axis from point A on this CN line, that is AT line. Now if we look at to the triangle OBM and the ACT, so two sides OB and AC are parallel and equal in magnitude, right? So OBM and ACT, if we see that OB and the AC both are the parallel as well as the with the similar magnitude. So considering that two sides OM and AT are also parallel, so this OM and the AT, that is also parallel, so we can write down that, so OM that equals to this OM that equals to AT, and with AT this LN line is also parallel and with the same magnitude, so that we can write LN. Okay, now from the geometry of figure, another equations that we find out, if we look at to that ON, so that ON is equal to OL plus LN, so we can write down ON is equal to OL plus LN. Now what is ln? So that we considered ln is nothing but AT, and that AT is OM. So we can say that ln is equal to OM. So further we write down ON is equal to OL plus OM, because ln is equal to OM. But if we see that this ON is the resolved part of the resultant R. If we consider this is the resultant and the resolved part pertaining to the x-axis, that is ON. And what is OL? So OL is a resolved part of force P on x-axis. And what is this OM? So OM is a resolved part of the force Q. Now if we resolved the part of resultant along OX, or we can say the x-axis, so we can write down that, so resolved part of R along OX, what is that? So total resolved part is ON, that is the resolved part of the R. Now what is ON? ON is OL plus OM. So that equals to, that means resolved part of R along X is equal to resolved part of P along OX plus resolved part of Q along OX. Okay, so this is resolved part of R along X, that is ON, resolved part of P along OX, that is OL, plus resolved part of Q along OX, that is OM. Now here we consider only two number of forces, that is P and Q. But if we want to use this principle, so it may be extended for any number of forces. Now to understand method of resolution of forces, we take one force system and that consists number of forces. So let us say consider four different type of forces, P1, P2, P3 and P4. So before that we just put a axis X and the Y. So this is axis X, this is Y dash, X dash, and this is axis Y, right? Now there are four number of different forces that we have to consider. So force number 1, that is P1, then force number 2, that is towards the center point of that axis, that is P2, and force number 3, that is P3, and the last force, that is P4, that is also towards the center point, so that we considered force P4. And the center point, if we mark with a point as point O, right? Now if we consider a different angle that forces are made with X and Y axis, so here P1 make theta 1 angle with X axis, P4 make theta 4 angle with X axis, P3 make theta 3 with X axis, and P2 make theta 2 angle with Y axis. Now here there are four forces considered with respect to some angle with different axes. And here if we consider this as a positive axis, so we can write this is our negative axis. Now if you want to resolve that in a particular direction of the axis, so how to resolve, that is required to understand. So for the resolution of the forces, we just develop that figure in some bigger scale. So here we have X axis, here we consider as minus X, this is minus Y, and this is Y axis. Again I draw different forces that is drawn in previous figure. So here it is P1, then it is P2, then P4. Direction is also very much important, and last one is P3. Right? Now if you want to resolve that along the x-axis and the y-axis, So how to find out the resolution of different forces? So if we start with the force P1, so P1 that is resolved with x axis, so it has one component with respect to the x and second component with respect to the y. Same way if you consider force P3, that will resolve with x and resolve with y, and force P4 that is going inside x component and the y component, and the last force that is P2 that is also goes inside x component and the y component. Now theta is given, so we can directly write down considering the force P1 and with respect to x, if this is a theta 1, so we can write down using cos, this is P1 cos theta 1, and this one is P1 sin theta 1. So these are the two resolved part of force P1. Same way if this is theta 4, so P4 cos theta 4, and here P4 sin theta 4. Here the angle is theta 3, so it is P3 cos theta 3, and here P3 sin theta 3. Here angle is theta 2, so P2 cos theta 2 and P2 sin theta 2. So these are the number of resolved part of the given forces. Now the forces acting along the x-axis, so if we consider this one, this one, this one and this one, these are the force component that is along the x-axis that is required to added, and the components that is with respect to the y-axis that is required to added. But the main thing is that we have to take care of the sign convention. So if we start with the summation of the forces, so we write down that sigma with respect to the x-axis, the summation of the force that is along x-axis, so that is P1 cos theta 1, first one, and second one is P2 sin theta 2. Both are towards the positive axis, so that is in positive sign convention sin theta 2. If we consider P3 cos theta 3, that is towards the negative sign, so that's why P3 cos theta 3. Same way minus P4 cos theta 4. Similarly, if we add the forces along y-axis, so that is P1 sin theta 1, this one against the positive sign, minus P2 cos theta 2, that is in downward direction, so along the minus y-axis, that's why it is minus P3 sin theta 3. So this one is also towards the minus axis, and plus P4 sin theta 4, that is along the positive y-axis. So the given system is converted into a simple form, and that form if we show, so that is a summation of the forces along x-axis and the summation of forces along y-axis, or we can write down that this is Rx and this is Ry. Now therefore magnitude of a resultant, if you want to give, so that R is equal to under root of sigma fx square plus sigma fy square. So this equation gives the total resultant out of the four forces, or we can say out of the number of component of that four forces. And if we look at to the direction of that with respect to the x-axis, so the resultant that we show here, so this is our resultant, and if we show the resultant of force in x direction and force in y direction like this is the resultant, and here is the angle, and that angle we consider as a alpha angle. So for that the equation is the alpha is equal to tan inverse summation of the forces in y direction divided by the summation of forces in x direction. So this way we resolve the number of forces, and with using these two equations we can find out the magnitude of the resultant and the direction of that particular resultant of the given forces. So this is all about method of resolution of forces.